In this tutorial I'm going to look at fossil fuels and a little later how it is that we can get useful products from crude oil. First of all, the connection between these substances is, of course, they are all fossil fuels. Top left we have coal, top right we have oil being pumped out of the ground, bottom left we have natural gas, and on the bottom right one lesser known fossil fuel, which is peat. Crude oil, sometimes known as petroleum, coal and gas, they're all fossil fuels. That means that they're dug out of the ground. They're all finite resources. That means that there's a limited amount in the ground. They're no longer being made, or at the very least it's going to take millions of years to make some more. Non-renewable means they're being used up faster than they're being made, unlike renewable sources of energy like, for example, wood. So here's part of the specification that we just covered, the fact that they're all fossil fuels and those meanings of finite and non-renewable. The parts in yellow are foundation only, and those which are in white are on the foundation and higher papers. You also need to know about fractional distillation, a method of separating crude oil into useful products, which are called fractions, and how broadly the process works. Crude oil is this sticky black substance which originally had no real uses. It was just painted onto the side of wooden ships to stop the water getting in. But it's when scientists discovered how to use fractional distillation to separate it into useful product that suddenly it became a very useful resource. A fractionating column or fractionating tower is used to separate the crude oil which goes into the process into a number of useful products, which you can see here the names of. Refinery gases is usually known as liquid petroleum gas. Then there's petrol, as us Brits call it, but there's also the American name gasoline. There's naphtha, frequently called paraffin on exam papers. There's kerosene, there's diesel oil, there's fuel oil, and sometimes mixed in with that lubricating oil, and finally the residue, which is often known as bitumen. Fractionating columns like this one shown here in real size are very, very large and are used by oil companies to separate that crude oil into more useful products. Crude oil contains compounds of only carbon and hydrogen. They're called hydrocarbons, but these carbon atoms can join in chains. It's actually called catenation, and these chains can be any kind of length, from very short ones, or the shortest one on the right, which is methane, which is a gas at room temperature. This one I'm highlighting now, which is called butane, which is also gas at room temperature, up to these longer chains which would be liquids at room temperature, or even longer ones which would be solids at room temperature. So these hydrocarbons have got all kinds of different lengths, and that's kind of the key as to how the crude oil is separated. Because these compounds, these hydrocarbons in crude oil, have got different chain lengths, that also means that they've got different boiling points, and that's really the key as to how the crude oil is separated into these different liquids, solids and gases. You need to be able to explain how fractional distillation does that job, so I'm going to cover that next. Crude oil is a real mixture. It looks like a liquid, but within that liquid there are gases dissolved in it, and also there are solids dissolved in it. And the liquid actually is a mixture of liquids of different boiling points. The first thing that happens to the crude oil is it's heated in a furnace to about 350 degrees, and at that temperature most of the components of crude oil will turn into vapor. So this mixture of vapors enters the column at the bottom. Any substances which at this temperature of about 340 degrees would be a liquid at that temperature will come out of the bottom as a residue. It's called bitumen. Let's take, for example, a substance that has a boiling point of 120 degrees. So below 120 degrees it's a liquid, above 120 degrees it's a vapor. Well, here it's around 340 degrees, well hot enough for it to remain as a vapor. So the vapor rises to the next section where it's 260 degrees. Again, it remains a vapor and rises into the next section. Here it's 180 degrees. 180 degrees, it's still hot enough to retain its form as a vapour, so it rises into the next section. But here it's only 110 degrees. And 110 degrees isn't hot enough to keep it as a vapour, and it will condense into a liquid and come out at this point. So this liquid would be part of the naphtha or paraffin fraction. In this way, the column separates the crude oil into broad fractions or mixtures of hydrocarbons with similar boiling points. And in summary, the important bits you need to understand is that crude oil is first of all heated to make all the liquids evaporate. It then enters the column mostly as a mixture of gases. The bottom is very hot, the top is cool, it's called a temperature gradient, and these hydrocarbon molecules rise up the column until they reach a section where it's not quite hot enough to keep them as a gas, and they condense. In this way, the crude oil separates into fractions, which are, I suppose, parts of the whole of the crude oil, where each fraction contains a mixture of hydrocarbons which have got similar boiling points within a particular range. The fractions with the high boiling points condense towards the bottom of the column, and those with the low boiling points condense and exit towards the top of the column. And because the liquid petroleum gas doesn't condense at all in the column, it escapes as a gas out of the top. That liquid petroleum gas contains substances like propane and butane gases, which are used as fuels. The short hydrocarbon chains have got low boiling points because of their weak intermolecular forces, and so they escape high in the column, whereas the longer hydrocarbon chains with their stronger intermolecular forces require more energy to separate them. They've got higher boiling points and condense lower down in the column where it's hotter. A few past paper questions. Crude oil is a fossil fuel. It's separated at an oil refinery into useful parts. These parts are called fractions. What's the name of the process that separates crude oil? That one would be fractional distillation. Two of the substances in the list of fractions that can be separated into crude oil. Which two? Need to put 2 ticks in the correct boxes. The ones we recognise as being fractions are diesel and petrol. Supplies of these 3 fossil fuels will eventually run out. Look at the information about fossil fuels. There's a table and also a pie chart. Which fossil fuel will still be available in 100 years' time? The answer here would be coal, because that's the only one which will still be available after 100 years. The other 2 will have run out. And secondly, which fossil fuel was used the least in the UK in 2005? That one is also coal, because its percentage use is the smallest. And these are the allowable answers for those questions I've just covered. Crude oil is a fossil fuel. Write down the name of one other fossil fuel. I'll go for here natural gas. Can be separated into fractions. The process is called fractional distillation. Look at the diagram. It shows how crude oil is separated. Put an X in the diagram to show the coldest part in the fractionating column. Your X should be inside the fractionating column, so I'm going to go for here because that's the section which is the coolest. LPG, paraffin and diesel are fractions from crude oil. Write down the name of another fraction. Well, we could go for bitumen. Here's the marked scheme. I went for natural gas on the first one. You could go for coal as well, or peat indeed. There's the X inside the column, but indeed anywhere within that shaded region would have been fine. And finally, there's a list of the different names of the fractions that you could have chosen, and also some of the allowable answers.